Alright, so now we're at the bottom of page 76 of our workbook, and we're talking about graphs of rational functions, and we've already done some graphing. You may remember we had the function y equals 1 over x, and we graphed that using the techniques of shifting, stretching, reflecting. And as we were doing the shifting, remember I said that think of these like axes, like as your asymptotes. You're going to shift those around to help draw on the graph. If we take a similar function of y equals 1 over x squared, it looks like this. It's like that this gets squared, become positive, and it's made steeper because the power is higher. But we can also graph this by the techniques of shifting, stretching, and reflecting. So let's take a look at that. You use transformations to graph f of x equals 1 over x minus 3 minus 1. So I'm starting out with the parent function. And I'm going to put these axes in purple. So here's my parent function. And here I'm going to label this. X equals 0 is my vertical asymptote. My horizontal asymptote is y equals 0. Okay, now let's think about how this shifted. So I have a horizontal shift of 3 to the right. And then 1 down. There's no stretch or reflection, so that's cool. Alright, so think of your axis. I'm going to shift the axis 3 to the right. So let's look at the origin for a moment. 0, 0 gets shifted 3 to the right and 1 down. So I'm going to put that there, and I'm going to draw these as dashed lines. So the first thing I want to do is graph these asymptotes. So I'm going to graph, this is x equals 3 is my vertical asymptote, y equals negative 1 is my horizontal asymptote. And now you might have to find a couple points here. So like you can find this point here and this point here. And then the other one here was kind of like halfway between here and up here. And halfway between here and here. And you might find it like we did in the polynomial section, is to go through and use your table of values to get some additional points. But you're going to need like 2 or 3 points to help draw this. I believe that's what you'll need to draw this in Alex. And then we sketch it out. So now let's talk about, okay, what if they're not one of these parent functions? So what if they're not one of these functions down here? So how do we graph rational functions in general? So you always want to make sure you got them reduced to lowest terms. That's always the key. So before you do anything else, reduce those to lowest terms. Factor and reduce. So we're going to first determine the intercepts, the x-intercepts and y-intercepts. Determine if the function has vertical asymptotes and graph them dashed lines. Determine if the function has a horizontal asymptote or slant asymptote. We won't be discussing slant asymptotes. You can kind of cross that out. And graph the asymptotes as a dashed line. Determine if the function crosses the horizontal or slant asymptote. You can check for symmetry. We talked about that a little bit before in the previous section. And then apply at least 1 point interval is defined by the x-intercepts, vertical asymptote, and it's where the function crosses a horizontal or slant asymptote. Okay, so let's see how we do this. So here's the function we're working with. So first we want to determine the x-intercepts. Now the key here to keep in mind, when you're working with a polynomial function, that where the polynomial function has no common factors, probably should put except for 1. You gotta keep in mind, if this is the case, then let me rewrite it up here. The numerator is going to give you the x-intercepts. So the x-intercepts are going to come from the numerator. So if you have a factor of x plus 3 in your numerator, then its x-intercept is going to be negative 3 comma 0. If you have a factor of x minus 2 in the numerator, then 2 comma 0 would be, flipping the signs there, would be an x-intercept. And you're going to be getting your vertical asymptotes from the bottom. So keep that in mind as we're going through this. So if I'm looking at this here, my x-intercepts are going to come from the numerator. Okay, so that means 2 is an x-intercept. So we write that as a point, 2 comma 0. Now to find the y-intercept, we evaluate the function at x equals 0. So we do f of 0, 0 minus 2 over 0 plus 3. That's a negative 2/3. So my y-intercept is 0, negative 2/3. Step 1's done. Let's go to step 2. In fact, before we do step 2, let's go and plot these. So I have an x-intercept at 2, y-intercept at negative 2/3. That's about here. Let's go and plot those points. Okay, so step 2, we're going to go after the asymptotes. So remember, we get the vertical asymptotes from the bottom if this has already reduced the lowest terms. So x plus 3 is going to give us a vertical asymptote of x equals negative 3. Now for horizontal asymptotes, top and bottom are degree 1, so that's case 3. Y is going to be equal to 1 over 1, which is 1. And then this is case number 3. So my horizontal asymptote, and let's put that here. I'm going to just draw that here. And we draw on the vertical asymptote. So that was said that was x equals negative 3. So it looks something like that. So just kind of sketching those in. Now it says determine if the function crosses the horizontal or slant asymptote. Well, crosses the horizontal asymptote. So in other words, I want to see, does this cross y equals 1? So to determine, I'm going to do the set function equal to 1 and solve. See if I get a real solution or not. My LCD here is x plus 3, so I'm going to multiply both sides by x plus 3. That will give us x minus 2 equals x plus 3. However, if I subtract x from both sides, I get negative 2 equals 3, and that's no good. So no solution. So it does not cross the horizontal asymptote, so that's going to be a no. And then we can check to see if we have any symmetry running around here. Well, if I replace x by negative x, I do not get the equivalent expression. So, okay, so we don't have a whole lot to go on here. But I want to get some additional points. And now we could go ahead and we can pick some points here and here and try to draw this out. But let's go and use our table of values. So I'm going to hit my table key. Let's clear that. And then I'm going to enter my function in. So I'll do my fraction key, variable key, minus 2 over my variable key plus 3. Hit enter. And, well, let's go and start this in negative 8. And we're just going to do it step of 1. So it goes up by 1 each time. Okay, so at x equals negative 8, we're at y equals 2. All right, so let's put that in there. Okay, that does help. And I'm not going to put every point here. I'm going to put maybe 6. That's 2.67, so maybe about here. Negative 5. Let's do negative 4. Negative 4 is at 6. So that's up here. So that gives us a pretty good idea what's going on this side here. It's looking something like this. And I didn't draw that arrow very well. It should be still coming down. Alright, so now let's go beyond negative 3. Notice it gives me an error message. Well, it should, because that's where my vertical asymptote is. It's possible for your graph to cross a horizontal asymptote, but it can never cross a vertical asymptote, because that's where the rational function is undefined. Alright, let's go over to negative 2. So that's at negative 4. Alright. I might do negative 1, so that's a negative 1.5. And we got a pretty good idea what this thing's looking like here. Let's go over to... Yeah, boy, that's really taking a long time to climb, isn't it? Let's see if we can get up here to 7. That's 1.5. So I'm kind of looking for a nice one that's kind of easy to graph. But now we have a picture of what's going on over here. I'm going to go through these 3 dots and sketch my graph. And if I remember correctly, I think they're, and Alex, they're going to have you graph the vertical and horizontal asymptote first, and then they're going to have you graph at least 2 points on each side, if I remember that correctly.